Hello class. Today we're going to do lesson 3.2, which is on parallel lines and transversals. So just as a reminder, a parallel lines are two lines that never intersect, they never touch. And a transversal is this line that cuts through the set of parallel lines. So when you have two parallel lines cut by a transversal, a few things happen. As we've learned in our previous lessons, we have corresponding angles that look like this. Okay, those two corresponding angles are going to be congruent if the two lines are parallel. Now, what does congruent mean? This is the symbol for it. It's really the exact same thing as saying equal. Okay, what if we have a pair of alternate interior angles? So this would be an example of alternate interior. They're on opposite sides of the transversal and inside the set of parallel lines. Well, alternate interior angles also will be congruent if the lines are parallel. All right, make a guess for the next one, which is alternate exterior angles. What do you think alternate exteriors will be? So this would be an example of alternate exterior, these two green ones. Alternate exterior are also congruent when the two lines are parallel. Okay, and then the last one that we're going to talk about today is consecutive interior angles. And consecutive interior are on the same side as the transversal and on the inside set of parallel lines. And this one is a little bit different. As you can see by looking at these two pink angles, they don't look like they would be equal. They're actually going to be supplementary. And what does supplementary mean again? It means that they add to 180 degrees. So if I were to add those two angles together, they would equal 180 degrees. Okay, if you're having a hard time remembering which all of these angles are, I encourage you to look at the 3.1, 3.2 handout. I also included it on these notes, although I know it's a little small on these notes. But take a look there because I have all of the different angles and then also an example of what it looks like. And just as we talked about at the top of these notes, I also wrote if they're equal or if they add to 180 degrees. So example 1, it says classify the following pairs of angles as corresponding alternate interior, alternate exterior, consecutive interior, vertical, linear pair, or none of those. Then we have to find the missing angle measure. And I wrote a hint there to use that 3.1 to 3.2 handout. That's going to be very helpful to you. So the first one, we're talking about classifying angle 1 and angle 8. Well, if I take a look at my handout, these are a pair of alternate exterior angles. And according to this, alternate exterior angles are equal if the two lines are parallel. So I'm going to write down alternate exterior. Now it says that angle 1 is 132 degrees. So if those two angles are equal, that means that angle 8 is 132 degrees. All right, taking a look at the next one, we have angle 3 and angle 5. Angle 3 and angle 5. I should erase the other marking because each one of these examples is going to be like a brand new set. So it's like that we didn't already do letter A, this is just a fresh example. So letter B, classifying 3 and 5. Well, if I'm using my handout, 3 and 5 look like a set of consecutive interior angles. So I'm going to write that down. Consecutive interior. And it says that angle 5 is 122 degrees. Consecutive interior angles add to 180 degrees. So that means that angle 5 plus angle 3 is 180 degrees. Well, since we already know that angle 5 is 122, that means that we have 122 degrees plus angle 3 is equal to 180. So solving for angle 3, we would subtract, and angle 3 is going to be equal to 58 degrees. Okay, now I'm going to start over like I have a fresh problem again. All right, letter C, classify angle 2 and 6. So here's 2, here's 6. All right, looking at my handout, this looks like a pair of corresponding angles. They're in the same position. Corresponding. And according to my handout, I know that corresponding angles are equal. So if angle 2 is 46 degrees, that means that angle 6 is also 46 degrees. Okay, looking at letter D, we have angle 4 and 7. Here's 4, here's 7. Now if I look at my handout, I'm looking at the diagram column. I do not see any of these that look the same. So I'm going to write down none. But we still do have to find angle 4 if angle 7 is 37 degrees. So one thing that I know is that if angle 7 is 37 degrees, that means that angle 3 is also 37 degrees. So those two angles are equal. This one's something else. Now, the relationship between angle 3 here, and angle 4, that makes a linear pair, or you could say that they're supplementary. It's the same thing, right? Looking at my handout. Okay. Those two angles would add to 180 degrees. So I have that angle 3 is 37 plus angle 4 equals 180 degrees. Okay, solving for angle 4, I'm subtracting 37 on both sides. So angle 4 is equal to 143 degrees. All right, taking a look at letter E. We are now classifying angles 5 and 8. Angle 5 and 8. Okay, looking at my handout, it looks like angle 5 and 8 are vertical angles. And what I know about vertical angles is that they are equal. So if angle 5 is 124 degrees, that means that angle 8 is 124 degrees. All right, and my last example for the front side, letter F, classifying angles 7 and 8. If I'm looking at my handout, I see that they look like a linear pair. Actually, they're also supplementary, and they're even adjacent. I know that the only word up at the top here that I really need to identify is linear pair, but just because they are all of those, I'm going to go ahead and I'm going to actually write down all of them. So they are a linear pair, which means they form a straight line. They are supplementary, which means they add to 180 degrees. And they're also adjacent, and that means that they are right next to each other. They share a same side. Okay, what I know about linear pair and supplementary is that they add to 180 degrees. So if angle 7 is 41, angle 7 plus angle 8 is equal to 180 degrees. Solving for angle 8, we get that angle 8 is 139 degrees. All right, that is the front side. Let's take a look at the back side. Example 2 says, use the figures below to find the following variables. In letter A, we are solving for x. Okay, so let's take a look at these two angles. I want to know if they are corresponding, if they're consecutive interior, alternate exterior. And I'm noticing that we have one at the top left, and the other one is at the bottom left. These are not one of the angles on my 3.1 to 3.2 handout. So I might have to do a little extra work here. I do know that if this angle is 64, that means that this angle is 64 also. And the reason is because those two are corresponding angles. Now, what I have here is I know that this angle that I'm marking blue and this one that I'm marking blue, those two form a linear pair, which means if you add them together, they're 180 degrees. So I'm going to go ahead and I'm going to do that. I'm going to say that 64 plus 4x minus 8 is equal to 180 degrees. Now I can solve just like I normally would. I'm going to look and see if I have any like terms. And I see that 64 and minus 8 are like terms, so that gives me 56. So now I have 56 plus 4x equals 180. Right, solving just like I normally would, I would subtract 56 on both sides to get rid of it. Now I have 4x is equal to 124. Okay, and then I need to get rid of that 4. So that's 4 times x. So opposite of times is divide. So x is going to be equal to 31. So I needed to solve for x, so that means that that is my answer. X is 31 degrees. Taking a look at letter B. What I'm noticing in letter B, we have to solve for both x and y. And if I were to take a look at this 120 degrees and y, they form alternate exterior angles. And I know that alternate exterior angles are equal. So that already tells me that y is 120 degrees. Okay, so that's half of my problem. Now the next part is I need to find x. So taking a look at these two angles that I'm identifying as blue there in the picture, x and y, which we know is 120, that makes a linear pair, which if you add those together, that is 180 degrees. So I know that x plus y, which we said is 120 degrees, equals 180 degrees. Solving just like we normally would, I would subtract 120 on both sides. So x is going to be equal to 60 degrees. X is equal to 60 degrees, and now we have answered that question because we solved for both x and y. All right, taking a look at letter C. Let's see, we've got a couple of different things going on there. We have to solve for both x and y. I do notice that I always like to look at the number that, like 136 here, because it's just a plain number and it doesn't have any variables with it. So I'm going to look at that one, and I notice that, let's see, 136 and 3y plus 31, those are alternate exterior angles, which means that those two are equal. So I know that this thing up here is 136 degrees. Okay, cool. So now I should be able to solve for y. We know that 136 is equal to 3y plus 31. And now we're going to solve like we normally would. So I'm going to get rid of that plus 31. The opposite of plus 31 is minus 31. 136 minus 31 is 105. equals 3y. And then 3 times y, how do you undo 3 times? You divide by 3. And you can use a calculator here. This gives us 35 is equal to y. So that is half of my problem right there. We have y is equal to 35 degrees. Okay, I also now need to solve for x. Now what I'm noticing is that we said that this angle, I just colored it purple, is 136 degrees. I need to now find this. Okay, those two form a linear pair. So that tells me that if this first one, 136 degrees, this thing right here, which we know already is 136 degrees, plus this other angle, 6x plus 8, that should equal 180, because like I said, they are a linear pair. Okay, and now I can solve like I normally would. I'm going to find my like terms, and I'm going to solve from there. So 136 plus 8 is 144, plus 6x equals 180 degrees. I'm going to get rid of that 144 by minusing it on both sides. Now I have 6x is equal to 36. This is 6 times x, so how do you undo times? You divide. So x is equal to 6. All right, I solved for both x and y, so that is my answer to that one. Letter D takes a bit more work, so I'm going to identify it as a challenge. And if you want to try it on your own, you're welcome to, and then you can check your work on the teacher's notes. On the last page there, we have example 3, which is where we can do a proof. I love proofs, but we're not going to take a lot of time to do them in chapter 3. So I'm identifying this one as a challenge as well. Again, if you want to try it, check your work on the teacher's notes, but this is not a requirement. Okay, that is our lesson for today. Thank you very much for watching, and see you next time.